So in this video, we're going to look at efficiency, or energy efficiency, I should say. So if you remember in the last lesson, excuse me, the first thing we looked at was the law of conservation of energy. And that's a really, really important rule that you need to learn. Energy cannot be created or destroyed, it can only change from one form to another. So last lesson, firstly we learned the different types of energy, and then we went to look at the law of conservation of energy and how energy changed from one form to another. In this lesson we're going to look at efficiency. Now what efficiency basically is, and you want to take a note of this, is really it is how good efficiency is a measure of how good something is at its job. And that will make a little bit more sense as we go through the video, but that's really what it tells us. If something is efficient at its job, it means it's really good at its job. If something is inefficient at its job, it means it's really bad at its job. So what do I mean by its job? Well, if you think of a light bulb, what's a light bulb's job? A light bulb's job is to give us light. Now let's look at the energy transfer for a light bulb. We know that light bulbs are plugged in, or they're connected up by wires, so the energy that goes in is electric. And of course, light bulbs give us light. But that's not the only thing light bulbs give us. Especially the old light bulbs tend to give us some heat as well. Now first of all, let's just look at the different types of energy here. If we wanted to label electric, we could say, well, that's the energy in. That's the energy that goes into the light bulb. And light and heat are the energies that come out. But there's a big difference between light and heat in that a light bulb's job is to give us light. So this energy is what we would describe as useful energy. That's what we want the light bulb to do. Heat, we don't want the light bulb to give us heat. It's a waste of energy. So this is described as wasted energy. And the first thing you need to do in these questions is identify, well, what's the energy in? That's usually the easy one. What's the useful energy? And what's wasted energy? Now let's put some imaginary numbers on this. Let's say 200, can you remember the unit of energy? Joules goes into a light bulb. And let's say 80 joules of that come out as light. Now you might remember we should be able to calculate how much comes out as heat because of the law of conservation of energy. What goes in must come out, basically. So if 200 joules went in and only 80 are accounted for coming out, that means 120 joules must be heat, because 120 plus 80 add together to give us 200. Now, how do we calculate the efficiency of its job, or this light bulb? Well, first of all, when you look at it, it doesn't look like it's very good at its job, does it? Because 200 joules are going in and we're only getting 80 joules of light for 200 joules that go in. There's a lot of wasted energy here. But we have an equation to figure out exactly what the amount of wasted energy is, or I should say the percentage of wasted energy. And that equation is the equation for efficiency. And you want to make sure you take this down in your notes as well. Efficiency is given by useful energy out, you could say, divided by total energy in. And when we think about efficiency, we think of it as a percentage. So to turn any number into percentage, we multiply by 100 over 1. So let's look at our example and calculate the efficiency. Well, when we go back to our light bulb, the useful energy out, in this case, is going to be 80. And the total energy in would be 200. So we'll go back to our equation. Useful energy out, we said, was 80. Total energy in was 200. Multiplied by 100 over 1. And what does that give us? 40%. And the unit of efficiency, as I said, is percent. Well, what does percent mean? Percent, you hopefully know already, means out of 100. A cent, there is 100 cent in a euro. A century is 100 years. So when you see 40%, what it means is that out of every 100, out of every 100 joules of energy put in, 40 joules are useful. That's what percent means. So in this case, 200 joules were put in, so in total 80 joules were useful. Could you figure out in your head that if 300 joules went into that light bulb, how many would be useful if it had a 40% efficiency? Well, for every 100, 40 are useful. So that would mean that 120 joules are useful in this case, are useful at light energy. And could you figure out how much is wasted then? Well, if 300 went in, 120 joules are useful, it must be 300 minus 120, which is 180 joules wasted as heat. So the last point I want to say just before I finish the video is that in every single energy transfer, there is some form of wasted energy. So what that basically means is that nothing is 100% efficient. So if you think of the laptop in front of you now, that laptop is obviously, it has a screen, and that screen is giving off light and it's giving off sound. But if you feel the laptop or computer in front of you now, you probably feel some heat at the back. And that's because energy is being wasted as heat in that laptop. And usually heat is one of the most common forms of wasted energy. So nothing is 100% efficient, and often energy is wasted as heat or sound. They're the two most common forms that energy can be wasted as.